Hello everyone, welcome back to my YouTube channel. I hope you're going with a model question paper of Model 1. So let us continue the same model question paper for Model 2 without wasting time. So welcome back for the session of model question papers for Model 2. The subject Introduction to Electrical Engineering. So you can see the questions, Model 2 questions 3 and 4. So I'll try to finish both the question in the same session. If time exceeds, so I'll upload one more video for Module 2 of question number 4. Okay. So many of you are having a few doubts in the problems. So nothing to worry. You can easily understand the problems and you can get the solution for the problems, whatever they asked in a model question paper, and it is just for your reference. You can see module 2, question number 3, first one, define following by referring a sine wave. So they asked 6 parameters that you have to define for 6 marks, so that each parameter is having one mark. The first one is RMS value, and the second one is average, form factor, peak factor, phase, and phase difference. Okay. So RMS value, root mean square. So you just have to write the definition because they just asked it for what, 6 marks. Each definition is having one mark, so that RMS value of an alternating current is nothing but, so I can define this as whenever steady current is nothing but DC current, DC. So when the DC that will be flowing through a given resistor for a given time, that resistor produces a heat, so that the same amount of heat will be produced if you're applying AC when flowing through the same resistor at same time. Means that you're giving a DC current to the resistor which will produce as heat. If you are supplying AC current also, the resistor that will produce as heat, but the amount of heat for given time that will be same. Okay, just for your understanding purpose. In textbook definition, you can observe, you can see here, when a steady current which when flowing through a given resistor for a given time that produces the same amount of heat as produced by the AC when flowing through the same resistor for the same time. Okay. Similarly, second question they asked, that is the second parameter, that is average value. So average value is nothing but by averaging all the alternating quantities. That's nothing but the average value of an alternating quantity is nothing but the value which is obtained by averaging all the instantaneous values, either it is a voltage or current, over a period of only half cycle. That is nothing but average value. Averaging of all the instantaneous values over a period of half cycle. Similarly, next is peak factor and form factor. They asked, the form factor is nothing but the ratio of RMS value of an alternating quantity to the average value of an alternating quantity. Similarly, peak factor is nothing but the ratio of maximum value of an alternating quantity to RMS value of an alternating quantity. And two more definitions, that is phase and phase difference. So in a waveform, phase is nothing but the position of the moving particle of waveform is called phase. Similarly, phase difference, the position is nothing but phase. Position of moving particle of the waveform is nothing but phase. Similarly, the phase difference is nothing but the time interval. The phase difference is nothing but the time interval by which a wave leads by or lags by another wave is called phase difference. And one more name is phase angle. Okay. And the second question you can see, show that current through purely capacitive circuit leads the applied voltage by 90° and average power consumed by is 0. Draw wave shapes of current, voltage and power for 8 marks. Means you need to draw the waveforms also. Okay. So that you should check the waveforms. Okay. So now it is nothing but they asked you to derive AC through pure capacitance. For AC through pure capacitance, consider a solution I am writing. Sorry. So consider a circuit which consists of capacitor C across AC supply. C across AC supply, that is instantaneous value of voltage V is given by Vm sine omega t, and current I is flowing through C. Whenever the supply which is given to the capacitor, parallel plate capacitor, the current starts to flow through this capacitor and it starts to charge. This capacitor starts to charge so that it has Q. So that charge is given by Q equals to C into V, where V is instantaneous value of voltage. So with reference of that, you can define current I is given by dq by dt, that is rate of change of charge. Okay, so here what is Q here? C into V. So I'm just substituting here I equals to d by dt of Q is nothing but C into V, whereas C is capacitance and V is voltage. So I can read it as C into d by dt of V is nothing but where V equals to Vm sine omega t, instantaneous value of voltage. So that Vm sine omega t. Okay, so if we're taking Vm outside, that constant Vm, that is C into Vm. So differentiation of sine omega t with respect to t is nothing but omega cos omega t. So you can read it here Vm. So omega c I can read it as divided by 1 by omega c cos omega t. So the trigonometry that says cos omega t you can rewrite as sine pi by 2 plus omega t, or sine omega t plus pi by 2. Sine omega t plus pi by 2 is nothing but cos omega t. Okay. So now sine omega t plus pi by 2. So you can write I equals to Vm divided by 1 over omega c, 1 by omega c, whereas omega is nothing but 2 pi, 1 by 2 pi f into c is nothing but capacitive reactance xc. So that you can write here Vm by xc into sine omega t plus pi by 2. This is equation number 1. So now compare equation number 1 with I equals to Im sine omega t plus or minus 5. If you want to consider, you can consider plus only, plus 5. So you can see now by comparing this, Im is nothing but Vm divided by xc. Im is nothing but Vm divided by xc, whereas xc is given by 1 by 2 pi f into c. And phase difference or phase angle, phi is nothing but plus pi by 2, means that there is a leading angle plus pi by 2. By observing these parameters, you can draw the phasor diagram. So here, for AC through pure capacitance, by considering voltage V as a reference, so now current angle is plus pi by 2 is nothing but leading angle. So that current which leads voltage at an angle of pi by 2. So that they asked, we can see the question. Current through purely capacitive circuit leads applied voltage by 90 degree. So this is proved. If you want, you can take screenshot. And the next word they asked, power consumed. You have to prove that power consumed is 0. So to prove that power consumed as 0, you have to define instantaneous value of power. P is given by instantaneous value of voltage and instantaneous value of current. Whereas V is given by Vm sine omega t, the reference voltage, and I is given by, just now we derived Im sine omega t plus pi by 2, that is leading current, whereas by taking voltage as a reference, current leads the voltage at an angle of 90 degree. Okay, so that P equals to Vm sine omega t into Im sine omega t plus pi by 2. But according to trigonometry, omega t plus pi by 2, sine omega t plus pi by 2 is nothing but cos omega t. So you can rewrite Vm sine omega t into cos omega t. And we know that sine 2 omega t is given by 2 into sine omega t into cos omega t. So that sine omega t into cos omega t is given by sine 2 omega t divided by 2. So that here you can rewrite the power with reference of this, can rewrite as instantaneous value of P is given by Vm, sorry, Im I missed. So Vm Im sine 2 omega t divided by 2. Whereas it has the frequency 2 omega t. The frequency of this equation is double the frequency of applied voltage. Double the frequency of applied voltage V, so that this power, average power becomes 0. That's what they asked. Power consumed is 0. This you have to write. Next, what they asked you to draw the waveforms, that is shape of current, voltage and power. So to draw waveform, first you should know phasor diagram. For AC through pure capacitance, voltage is a reference, current leads the voltage at an angle of 90 degree. So that now we can consider with respect to omega t, voltage, input voltage. So it will be having sinusoidal waveform. So now it has sinusoidal waveform for voltage like this. This is V equals to Vm sine omega t. So what current leads the voltage at an angle of 90 degree, so that there will be a leading current of 90 degree, so that but the magnitude of current that will be less than the magnitude of voltage, so that minus 90 degree. So here it is 0, it is pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi. Okay. So now current waveform. Current leads the voltage by what? 90 degree. See here, current leads the voltage by 90 degree. So this is a current waveform. Current is leading the voltage at an angle of 90 degree. Like this. So this is nothing but I equals to Im sine omega t plus pi by 2, current shape. So now we have to draw the what? Power. To draw power, you should take some intervals. With the help of intervals, you have to draw the power. That is nothing but a 0 to pi by 2 is one interval. Similarly, pi by 2 to pi is another interval like this. For every 90 degree, you will be taking the intervals. And you are comparing the voltage and current waveforms, you are drawing the power waveform. So for 0 to pi by 2 intervals, for this interval, just observe voltage waveform is positive and current waveform is positive. We know that P equals to V into I, so that plus into plus, you can get plus only, so that a waveform of power is positive. But the amplitude that will be more, like this. Similarly, for the second interval from pi by 2 to pi, voltage is positive, current is negative, so that plus into minus, you can get minus, so that power becomes negative like this. And the interval that continues like that by multiplying the voltage waveforms and current waveforms. See, that's it. This is P and average power will be 0. Positive half cycle, negative half cycle, that becomes 0. P average equals to 0. So this much you have to write it in examination. For first point, we'll be having 2 marks. For phasor diagram, 1 mark. Okay, 2 plus 1, 3. Then second one, power consumed, that will be having 5 marks, sorry, 3 marks. Sorry, 2 plus 1, 3, 8 marks they asked. So left out with the 5 marks, 2 marks is for power derivation and 3 marks will be for waveform. The waveforms you should have to write, that is having the weightage. So these 2 marks which include circuit diagram also. Okay, so this is the explanation that you have to write in examination. So what and all you have to write? So you have to write a circuit diagram and I equals to, sorry, first you need to write Q equals to C into V, then I equals to dQ by dt. Then you substitute the value of Q, you can get d by dt of C into V. Then you substitute the value of V, you can get d into dt of C into Vm sine omega t. So you're comparing this now, you can get I equals to C into Vm omega cos omega t, whereas you're writing cos omega t, rewriting with the help of sine. So omega into sine omega t plus pi by 2, and you're rewriting here Vm divided by omega c into sine omega t plus pi by 2. You are comparing this equation with Im sine omega t plus phi. So whereas Im equals to Vm by omega c, 1 by omega c is nothing but xc, that is nothing but 1 by 2 pi f into c. Similarly, phi is plus pi by 2, leading angle, and Im is Vm divided by xc. Okay, this is 1 by omega c, xc. Okay, so now we are drawing the phasor diagram by taking voltage as a reference. Current leads the voltage at an angle of 90 degree. Then with respect of that, you're drawing the waveform, voltage waveform like this, and current waveform will be starting from minus 90 degree, that is leading current like this. This is V and this is I. After that, you are drawing, you are deriving power. Average power is given by V into I. You are substituting V equals to Vm sine omega t and I equals to Im sine omega t plus pi by 2. So after deriving this, you can get average power equals to 0. Then again, you are taking intervals. You are taking the intervals and drawing the power waveform. For every 90 degree, you are taking the intervals. Every 90 degree. From here to here, power is positive and here power is negative. Like that, positive, negative, positive, negative, it will go on. P average equals to 0. This much you have tried in an examination. Okay. And third question. So they are given a problem, you have to find parameters of circuit. They gave what? Inductive coil. So inductive coil is nothing but there is a inductance with a small internal resistor. Inductance with a small internal resistance will be having L and R across supply voltage V. So this inductive coil takes a current of 10 amperes. So that I equals to what? 10 amperes, they are only given. And it has a voltage of 100 and frequency of 50 hertz. And they are given, there will be what? This current current lags the voltage by 30 degree. Current lags the voltage, that is angle between current and voltage is 30 degree, plus 30 because of lagging current. If there is a word called lagging, the angle becomes positive, plus 5. If the word leading, that will be minus 5, just for your reference. Okay. And they asked you to find the what parameters of circuit. So what are the parameters? L and R you need to find. Okay. So to find L, they are given some hints. V they are given, I they are given. So how will write Z here? So magnitude of Z is given by square root of XL square plus R square, or as per your textbook if you wanted to write. So you can write as R square plus XL square. R square plus XL square. But to get this Z, we don't know the value of R also and XL also. But they are given a hint. There will be a voltage V, that is 100 volts, and also there will be a voltage, there will be a voltage V equals to 100 volts, and frequency is 50 hertz, and I is 10 amperes. We can get Z, magnitude of Z directly. Z equals to V divided by I. That's nothing but 100 divided by 10. You can get 10 ohm Z, magnitude of Z. So if you have a magnitude of Z, they are given angle phi. Phi they are given, that is 30 degree. So that you can easily get cos phi, power factor. Cos phi equals to cos of 30 degree. So cos 30 degree is nothing but, so I'll just check, cos 30 degree 0.866. So why you are calculating this? Because you know that cos phi is given by R divided by Z, magnitude of Z. You know cos phi, you know magnitude of Z, you can get the value of R. R equals to Z into cos phi. Whereas Z is 10 and cos phi is 0.866. So you can get R equals to 88.66, I guess, into 10. 8.66 ohm. That's it. So if you get the value of R, you can get the value of XL now. Then with the help of XL, you are getting the value of L. Okay. So if you are having confusion, you just look into here. They are given the value of voltage 100 and they are given the value of current 10 amperes and they are given phi, that is plus 30 degree, and frequency 50 hertz they are given. They asked you to find parameters, means inductive coil is nothing but R and L circuit, RL circuit. So that parameters is nothing but Z you need to find, L you need to find, R you need to find, XL you need to find. These are the parameters. So to find these parameters, they are given hints. Z you can easily get, Z is given by V divided by I. So you can get 10 ohm. And 30 degree they are given. First you calculate power factor, that is cos 30 degree is nothing but 0.8660. 8660. So once after calculating the power factor, second point is also finished here. Next you can calculate R. So the next parameter is R. So if you can define cos phi equals to R divided by modulus of Z. So you can get R equals to Z into cos phi. That is nothing but 10 into 0.8660. You can get 8.66 ohm. Next, you need to find the value of XL, then L. So to find XL, you know that impedance, the modulus of Z, the magnitude of impedance is given by square root of R square plus XL square. So you can get XL square equals to, or else XL equals to square root of Z square plus R square. That is nothing but square root of 10 square plus 8.660 square. Sorry, XL is Z minus R square. I'll rewrite. Sorry. So Excel you can write. Excel is z square minus r square. Square root of 10 square minus 8.660 square. So how much you'll get? 10 square minus square root of that. So you can get 5 ohm. Excel is 5 ohm. So R you are getting now. Excel you are getting. Z you are getting. These are the parameters. Next you need to find L. So to find L, you know Excel is given by 2 pi f into L. So that L equals to Excel divided by 2 pi f. Whereas Excel is 5 divided by 2 pi into 50. So 5 divided by 2 pi 50. You can get 0.0159 Henry. If you want to write in terms of millihenry, so you can write 15.9 millihenry. So the first point is finished. So now what they are, second point, power factor. So you already calculated the power factor, that is 0.866. Okay. So what is the third point now? The first point finished, second point finished, third point active, reactive, apparent power. Whereas active power is nothing but P equals to modulus of V, modulus of I, cos phi. You already know cos phi, you know the value of phi. Phi is plus 30 degree, lagging angle. V is 100 into 10 into 0.8660. You can get active power in terms of watt. That's nothing but 100 into 10 into 866 watt. Next, reactive power, Vi sin phi, that is nothing but 100 into 10 into sin phi is nothing but sin 30 degree. So how much you'll get? Sin 30 is nothing but 1 by 2, I guess, into 500 you will get 500 VAR unit. Similarly, apparent power V into I, 100 into 10, you can get 1000 VA. So these are the answers. So if you're having any doubts regarding this, feel free to write in a comment box. So I'll reply anyhow. And this is the module 2, that is a third question number 3 in model question paper. So I think it gets time now. So I'll upload one more video for module 2. That is question number 4 of module 2. I'll upload very soon by next session. So that feel free to discuss in the comment box. So you just have to write these all things in examination if they asked. So you can observe one thing. So in this question paper, you can see for module 2, they asked 2 problems in question number 4, only one theory. Similarly, here you can see one derivation you can expect. See here, RL they asked, C they asked. You can expect any one derivation from R, L, C, any one. Or else you can expect any one combinational RL, RC, or else RLC circuit combination. And one problem from three-phase circuit. You can get one problem from three-phase circuit and one problem from one or two problems from single-phase circuits. That is RL, RC, RLC problems. One derivation. Okay. So just you should be very aware to write an examination. so that nothing to worry. So you can easily understand the concepts. So just follow my YouTube channel. If you're having any calculation difficulties also, so I uploaded few videos regarding for complex form and how to convert complex to polar, polar to rectangular, and rectangular to polar. Similarly, how we can calculate the equations, everything can get in a playlist. Just go through that and you just check with that. Okay. So I hope you enjoyed the session and it will be very helpful for examination point of view, so that you should know how to write in examination, how to convey the answers in a answer sheet to the evaluator, so that so be serious and prepare well for the examination. All the very best. I'll come along with question number 4 very soon for the next video. Thank you so much for watching this video, and please support the channel, and also make sure if you're understanding the concept. If you're not at all, means you just write in the comment box. I'll respond. And also please do share as much as possible, and also don't forget to subscribe. Thank you so much.